Okay, so we've been talking about quadratics. And when we started this chapter, we talked about there are going to be four main skills that we're going to worry about. So those four skills are simplifying, solving, graphing, and modeling. And to this point, been working on the simplifying piece. And we started by talking about the three forms that we can write a quadratic. And I'm just kind of recapping some stuff that we did because we left off somewhere. We've taken a big detour to spend all this time practicing factoring. I just want to refresh our memory of kind of where we were at and what we're doing and where what we're about to do fits into what we've already done. So there was the standard form. There was intercept form, which is kind of like factored form. And then there was vertex form. And I don't remember the order that we wrote these earlier when we listed them before, but this is the order that I'm listing them in now. And these should all kind of ring a bell, right? These are all things that we kind of worked with a little bit in worksheet 1 earlier. And then we spent some time moving back and forth between these forms. Right, and we drew this little diagram that had how we move back and forth between these different forms. So the piece that we haven't yet talked about is this completing the square piece. That's what we're going to spend some time doing here today, at least to start with. And I'm just going to kind of pause here for a minute, let everybody kind of catch up before we dive into something new. So when we say this completing the square technique, this is going to be, hopefully, obviously, the opposite as expanding, right? It's going to be basically the reverse of what we do when we expand. Everybody okay with that reasoning? That should be kind of obvious from looking at the picture. So I guess to start, what I want to do is I want to look at an expanding problem, and then I'll use that to justify the steps that we're going to take to do the completing the square problem. Is that okay with you guys? Okay. So let's say we have x squared, or x plus 2 quantity squared, minus 3. So that's something that's in vertex form. And we're going to expand that to get it into standard form. So remember, when we say expand, that's talking about dealing with this parenthesis squared, right? And we said that the way we deal with that is we can just write it out as x plus 2 times x plus 2, right? If I had 5 squared is just 5 times 5. So x plus 2 squared is x plus 2 times x plus 2. And then we can just FOIL this out. Everybody's okay so far? Okay. So I do x times x gives me x squared. X times 2 gives me 2x. 2 times x gives me 2x. And 2 times 2 gives me 2 squared. I'm going to leave it as 2 squared instead of 4 for a moment, just to kind of justify what we're about to do. But I'm going to write it as 2 squared there. And you'll see why in a minute when we start tracking backwards to develop the completing the square method. And then we went ahead and added those like terms in the middle there. So 2x and 2x gives us 4x. And then I can rewrite 2 squared as 4. And I can combine the like terms. So 4 minus 3 is just 1. Is everybody okay remembering doing this? And I did some extra steps there. And again, I only did those extra steps this time, or I didn't do a couple of things right away, just so that when we look at this as to go backwards, it's a little bit more clear why I'm going to do what I'm going to do. But certainly you could have compressed some of these steps together if you're doing this problem by hand on a test or a quiz or whatever, and that's fine. Okay. So let's go from the standard form back to vertex form. So I'm going to start with what we ended with. Boy, I picked a dumb thing to do here, but oh, that's fine. I regret picking x plus 2 as the thing in the parentheses. Would anybody get too mad if I change that real quick to make it less obvious? I'm just going to erase some stuff and write in some new values. It'll be a little bit easier to see what's going on if I change this to like a 5 or something. I apologize. Oops. Okay. So again, I'll give you guys a second to, if you were making edits. I apologize for not planning that out a little better, but it was one of those, like, it doesn't really matter, but when I go and I'm doing what I'm about to do, I'm like, ooh, that was a poor example to pick. And I'll explain why in a moment. Everybody's okay there. All right. So in walking backwards, the first thing that I need to do is I need to think about how I'm going to get this like x plus 5 squared piece back. So that is going to get, I'm going to retrieve that part by having to factor something. So if I look at what x plus 5 squared was, or turns into, it's that polynomial there, right? Everybody's okay with that? If I look over here, I have the x squared plus 10x part, but I don't have that last piece correct. Right now I have plus 22 rather than plus 25. Everybody's okay there? We can see that? So what I'm going to do is I'm going to look for a relationship between this 10 and this 25. How can I take 10 and turn it into 25? What if I divide it by 2 and then square it? 10 divided by 2 is 5, and 5 squared is 25. Everybody kind of see that? The relationship between that middle number and the number on the end? So we're going to just take that x coefficient, divide it by 2, square it. Let's start writing in red now. But I can't just add 25 to this because it's not an equation, right? If I add a 25 there, I've inherently changed the value of this polynomial. So what else should I include to make sure that makes it so I really haven't done anything? I'm also going to subtract 25. So if you look at this, have I really done anything? It's the exact same polynomial I've started with. I just have a plus 25 and a minus 25 tacked on there, which is the same thing as not really doing anything at all. Are we okay with that? The point is, though, if I look at just this part, that's something now that I can factor into two identical pieces. So if I look at this, the two numbers that multiply to give me 25 and add to give me 10 is 5 and 5. Jacob? Yes, absolutely. Is everybody okay with that? Now I'm going to combine this piece. Negative 25 and 22 is just negative 3. And I know if I have a number times itself, that's the same thing as the number squared. So I can just write x plus 5 times x plus 5 is x plus 5 squared. And then I'm done. So what did I do there? I factored and I simplified, right? So I combined the negative 25 and the positive 22, and then I factored the other quadratic part there. So this kind of quadratic polynomial that factors into two identical pieces is called a perfect square. And that's when we say completing the square, that's what we did on this very first step when we added 25 and subtracted 25, is I created a perfect square polynomial there that I could factor. Now I had some leftover stuff after I did that, but that's fine. Let's try another. Sound good? But that's the idea. That's the general procedure. Okay? So let's say we have x squared plus 6x plus 8. So what number do I need to consider here to figure out what I need to add and subtract here on the first step? I need to look at the 6, the coefficient on the x. What do I do to that number? I divide it by 2, and then I square it. And that's what I need to add and subtract then from my polynomial. I would write it that way so it doesn't look wrong. So then I'll write a plus 9, a minus 9, and then I still have the minus 8. Is everybody okay with how I figured out that the number I needed was 9?
Mr. Kulik, I have a question.
Yeah.
I'm in the room. So did you not have to FOIL on this one?
So I used the previous example.
Okay.
What I did on the previous example is I noticed that these two processes are opposites.
Okay.
So I used this process, the expanding process that I knew how to do, as like my template for how to go backwards.
Oh, I understand. Okay, that sounds good. Thank you.
You're welcome. Okay. Any questions about how we got to here? All right. Well, it's time to factor that out. So the two things that multiply to give me 9 and add to give me 6 are 3 and 3. They should always be the same number. And then negative 9 minus 8 is negative 17. And then I can write x plus 3 times x plus 3 as just x plus 3 squared. And I still have that minus 17 hanging out at the end. And that's it. So far, so good. Hopefully this doesn't feel too hard, right? Does it get trickier than this? Well, yeah, a little bit. So let's do another example. And if you notice here for a moment, if you look at all these previous examples, what has been in common? If we look at this example and the previous one that we did, notice that the leading coefficient was 1 in all of those cases. It gets a little bit trickier if the leading coefficient isn't 1, because we have to add some extra steps in here to deal with that. But let's do that, okay? So let's look at an example where we have a leading coefficient that isn't 1. Oops, I don't want 18 there. Let's make that 16. Sorry. Okay. So here we have an additional first step. That first step is going to be to take this part, and we have to get rid of that leading coefficient. So we'll do that just by factoring a greatest common factor of 2 out of there. Is everybody okay with that? So no big deal on that first step, right? That seems reasonably easy to do. Now if I look at this piece, the part that I need to consider is the 8. So I need to take 8, divide it by 2, and square it. So that should be 16. Everybody okay there? Now here's the tricky part. So I'm going to put a plus 16 and a minus 16 in here. Where do they need to go? Inside the parentheses or outside the parentheses? They have to go inside because that's the part that I'm trying to factor. And I need to have all the stuff I'm going to factor all in the same spot, right? So wherever the x squared and the x is, that's where I have to put the plus and the minus. Is everybody okay with what I've done there? Now we have a new issue, though, that we've created because of this. I need to ignore that negative 16, right? How am I going to ignore that negative 16? I need to get it out of those parentheses if I want to ignore it to do the factoring. So what I'm going to do is I'm just going to distribute the 2 only to the negative 16. That kicks the negative 16 out of that set of parentheses. Is everybody okay with that reasoning? Now, if I look at this, I can factor this. So 2 things that multiply to give me 16 and add to give me 8 are 4 and 4. 32, or negative 32 plus 15 is negative 17. And then I can rewrite x plus 4 times x plus 4 is x plus 4 squared. And I'm done. So that one had a little bit of extra algebra to deal with because of that leading coefficient floating around there, right? But not so terrible. Let's do one more like that, and then we can move on to the next topic. Okay? Okay, first thing I need to do is I need to factor that 3 off of just the pieces that have x attached to them. We good there? Right, that's our first step. Then we're going to look at the 6. So 6 divided by 2 squared is 3 squared, or 9. So I'm going to put a plus 9 and minus 9 inside the parentheses. Again, it's okay to do that because I'm really not doing anything, right? Adding 9 and then subtracting it right away is the same thing as just adding 0, and I haven't done anything. So far, so good. Now, we need to kick that negative 9 out of the big parenthesis there. So we do that just by distributing the 3 to it. And now we're ready to factor. So two things that multiply to give me positive 9, but add to give me negative 6 are negative 3 and negative 3. And negative 27 plus 5 is negative 22. And x plus 3 times x plus 3 is just, x minus 3 times x minus 3 is just x minus 3 squared. And we're done. Everybody okay there? Okay. That's kind of closes the door on the simplifying side. So we've gone and talked about how to convert between all these 3 different forms. We've talked about the simplifying techniques that we use to kind of change in between these forms. So I think we're ready to move on and start talking a little bit about solving today. And this will be another rather big topic. Here we'll spend a couple of days talking about solving techniques. As there's several things we need to address here. So the first thing that we're going to deal with is let's see, where do I want to come at this from? I'm just trying to organize my thoughts here as to where is going to be the most accessible place. Yeah, we'll do it that way. Okay. So depending on which form our quadratic is written in, our solving technique will vary a little bit. So this is probably the best way to kind of organize this, is to think about it by form, the representation that it's in. So we'll start with the easiest situation, which is if we have something that's in intercept form. And we're going to take advantage of a very important property here, which is called the zero product property. And what the zero product property says is if you have two things that are being multiplied together and they give you 0, this is true if and only if one or both of those two things is equal to 0. Right? If you multiply two numbers and get 0, the only way that can happen is if at least one of those two numbers was 0, right? That's the only number that you can multiply by and get 0 at the answer. Everybody agree with that? Okay. So for example, if I have this problem of x plus 2 times x plus 3 equals 0, I can use the zero product property here because I have two things that are being multiplied together, right? The symbol in between the parentheses is multiplication. And that multiplication problem is equal to 0. Does everybody agree with that? Note that it doesn't matter that there's addition and subtraction going on inside the parentheses. It's the fact that I have one parenthesis times another parenthesis equal to 0. Everybody's okay there? So applying the zero product property, I can then say that x plus 2 is equal to 0 and x minus 3 is equal to 0. And now I can solve each one of these two separately, which is very easy. I subtract 2 from both sides to get negative 2. And I add 3 to both sides to get positive 3. So those are my answers. That's pretty nice, right? Let's do another example. Actually, we'll just call that example A. How is this problem different from the previous one?
There's a 3, a negative 3.
Yeah, we have this negative 3 out front, right? Is that going to make any difference to us, though? Not really. So again, I can apply the zero product property, but how many multiplications do I have going on here? I really have 3 things that are being multiplied together, right? Can everybody see that? So when I apply the zero product property, I set each one of those 3 things equal to 0. Now what's the solution to negative 3 equal to 0? Just use some common sense here, folks. Does negative 3 equal 0? So what do we say for that one? Just that has no solution, right? Clearly that's a bunch of hogwash. There's nothing to do there. But the other two, no problem solving. I can add 5 to both sides and subtract 7 from both sides. So my answers are 5 and negative 7, and that extra number out front really posed no hurdle at all. Everybody okay to hear? Now, notice that I don't necessarily have to be given a polynomial already in intercept form to be able to use this, right? What if we give you a standard form polynomial like x squared plus 4x plus 3 equal to 0? As it's written right now, we don't have a method to solve this. But could we rewrite this standard form polynomial as an intercept form polynomial? Yes, right? How would we do that? By factoring. So how does x squared plus 4x plus 3 factor? What does that factor to? Anybody want to shout that out? Good. 1 and 3, so x plus 1 times x plus 3. And now it's easy like it was before. So I can subtract 1 from both sides to get negative 1, and subtract 3 from both sides to get negative 3. Is everybody okay with that one? We can see now one of the reasons why factoring is such a powerful technique, right? Is that it makes solving quite easy in many situations. What if we have something like x squared plus 7x minus 10? Well, right away we have a big problem here, right? What's the big problem right away? It doesn't equal 0. But we can fix that, right? We can just add 10 to both sides so that it does equal 0. That was an easy hurdle to clear. Everybody's okay with that? Again, you cannot use the zero product property unless it's equal to 0. So that's straight off, first and foremost, we get that polynomial equal to 0. And now we can try to factor this. Two numbers that multiply to give us 10 and add to give us 7 are 2 and 5, right? So now I can set each of those factors equal to 0 and solve. So subtracting 2 to both sides, I get negative 2. And subtract 5 from both sides, I get negative 5. Do we feel okay doing that? That's good. Here's the question. What's the drawback here? Right? What's the problem? Why is solving going to take a couple of days if this has all been so easy so far?
Maybe a value for x. Is there going to be like a new value for x?
A new value for x.
Probably not right, but I was just...
Yeah, let's ask this question. What if we tried to solve this one? What's the problem? Are there two numbers that multiply to give us 1 and add to give us 1? Not integers anyways, right? So the drawback is, the catch, not every polynomial is factorable using our methods. So we're going to have to extend this a little bit, but we're going to wait till next time to start to do that. Okay? So I just wanted to put that out there as a kind of a foreshadowing for what we're going to be doing next time, because we still need to deal with that sort of a situation. And at this point in the homework, if you encounter something, at least until we meet next time when we kind of try to fill this gap a little bit, that is not factorable, we're just going to say, we're going to say, where you just would say not factorable or whatever and just move on. Eventually, we're going to talk about how to solve those ones too, but we need another day to get to the point where we can do that. I want to do a few more where the factoring maybe becomes a little bit trickier. Everybody's okay with that plan? So we're just going to continue doing some more solving examples. I just wanted to introduce that idea before we got carried away and we're like, oh, just everything is easy. Well, it is, but maybe not as easy as we hoped. So what's the right away here? You should notice something. Notice the coefficient isn't 1, right? If I look at the rest of my coefficients, can I factor a 6 out of everything else? No. So we're going to have to use the long factoring method to do this, but that's okay. We've practiced that. It's been a minute since we've gone and done one of these, so let's review how to do that again. So we want to find the two numbers that multiply to give us 6 times negative 15 and add to give us negative 1. So A times C for the multiplication, and then B for the addition. Anybody see those two numbers here off the top of their head? It's not too hard to see them.
Negative 10 and 9.
Negative 10 and positive 9 is the pair. Thank you. So remember what we do with that. We replace the negative 1x with a negative 10x plus 9x, and then we make two groups. Now we're going to look for a greatest common factor in the first group. So between 6x squared and negative 10x, our greatest common factor is 2x. Yes, very good. So when I factor the 2x off, 6 divided by 2 is 3. X squared divided by x is x. 10 divided by 2 is 5. X divided by x is just 1. So there's nothing to do there. Now let's look at the next set. What is our greatest common factor there? 3. So 9x divided by 3 is 3x. 15 divided by 3 is 5. Now if I look at these as two separate pieces and I look for something in common, we notice there's a 3x minus 5 in each of them. That leaves me with 2x plus 3. So there's our factored form. Now that it's factored, I can apply the zero product property to set each of them equal to 0, each factor equal to 0. So I can add 5 and then divide by 3. And then I can subtract 3 and divide by 2. We okay there? Good. I'm going to give one more, and I'm going to let you guys work on this one. on your own. I'm going to write on the side the answers so that when you finish, you know if you've done things correctly or not. I'm going to write those answers as fractions. You could turn them into decimals maybe if you wanted to. I advise against it. Move that up to the top there. So take some time here on your own. Try to work this one out on your own. This will be the last thing that we do today. While you guys are working on this, I'm going to get some homework together for you and get that into the content library on OneNote here. I may not have it up there by the end of class, but we'll get it in there by the end of the day, definitely. Sound good to you guys? Oh, good. Hopefully today wasn't too bad. Yes. Okay.
Did I miss anything from the plan, or was it just practice stuff in the knowledge? I like to kind of.
Yeah, it was. We did a bunch of these time factoring practices, and then I had you guys help me out with something on OneNote,
Oh,
so you didn't miss any new content.
all right.
There was no assignment. So,
All right, thank you.
yeah, you're welcome, Marco.